Hi folks, let's talk about the study guide. So we'll go over the first 13 questions. Make sure you've done them before you watch the video, and I'll try to go through this really fast. So define updraft, current of rising air, insulator, poor conductor of electricity or electrons, which is what electricity is made of. Number 2, both the Bergeron process and the collision coalescence process explain precipitation, but they begin with a different kind of cloud. What kind of cloud does each begin with? So the Bergeron process is a cold cloud at the freezing point of water or below, and the collision coalescence process is going to happen in a warm cloud above the freezing point of water. Maybe that doesn't seem warm to you, but if it's above the freezing point, you know. Number 3, which of the two theories of precipitation governs the fall of rain from the top of a cumulonimbus cloud? That would be Bergeron process, because that would be a cold cloud. And of course you know that cumulonimbus clouds tend to come in on cold fronts, which are moving in on warm air masses. So you can remember that cumulonimbus clouds are coming from cold fronts, so you know that they're cold clouds. They're going to be Bergeron process clouds. Here we go. What kind of rain cloud would most likely be described by the collision coalescence process? Well, warm clouds, and you know what kind of clouds come on warm fronts. That tends to be stratus clouds. Number 4, what is the size difference between drizzle and rain? Well, rain tends to be about 2 millimeter or larger droplets, and drizzle tends to be much smaller droplets, maybe 0.5 millimeter or smaller. And number 5, what are the differences between sleet, hail, and freezing rain? So sleet is rain that freezes as it falls, going through a cold layer. Freezing rain is rain that freezes once it lands on something, but actually falls as liquid and doesn't freeze until it hits a cold surface. Hail is when rain or ice gets blown up and down and up and down, and one of those cumulonimbus clouds, and layer upon layer upon layer of ice freezes. It tends to happen when a cold front is coming in, lifting up a warm front. That's pretty much often when you get the type of thunderstorm or cumulonimbus cloud that can do things like hail, tornado, big thunderstorms. Number 6, the meteorologist measures the dew point on 2 different mornings. The first morning is humid and atmospheric pressure is high. The second morning is not nearly as humid and atmospheric pressure is lower. On which day will the dew point be the lowest? So remember the rule from the last video. High pressure, high humidity means high dew point. So on the second day, the dew point will be the coldest, because that has lower pressure, lower humidity, so lower dew point. Remember that dew forms when water vapor hits something cold and condenses. Frost forms when water vapor from the air hits something really cold and just immediately freezes instead of becoming liquid. 7, name the 3 stages of thunderstorm cells in the order they occur, and indicate if there's updraft, downdraft, or both, and whether or not precipitation would be occurring during that phase of the thunderstorm. So, first phase of a thunderstorm is the cumulus phase, not to be confused with the cumulus cloud. You know thunderstorms always come from cumulonimbus clouds. So during the cumulus phase of a thunderstorm, you have an updraft only, and no precipitation yet, because everything's going upward with that updraft. The second phase of the thunderstorm, mature phase, you have both the updraft and the downdraft. It will have started to rain at that point, and certainly this is the time when lightning is possible during thunderstorm. And the third phase, the dissipation phase, then you've got a downdraft, but not an updraft anymore. The downdraft has completely overcome the updraft at this point, and rain will have lessened at that point. It may still be raining, but rain will be lightening. Number 8, if heavy rain of a thunderstorm lasts more than 30 minutes, what can you conclude? One cumulonimbus cloud is probably going to rain itself out or pass you by within 30 minutes. So you have multiple thunder cells, multiple cells in that thunderstorm, multiple cumulonimbus clouds in a big line, which tends to happen as a cold front moves in on a warm front. You would form a row of thunderstorms all along the boundary line between the warm air mass and the cold air mass. Number 9. Lightning forms as a result of an electrical charge imbalance. Where does the imbalance originate and why does it occur? So the imbalance originates in the cloud. I'll just read what I have so I can be a little faster. Ice crystals near the top of a cumulonimbus cloud get heavy and fall. When they collide glancingly with water drops or other ice crystals, they can steal electrons and fall to the bottom of the cloud. Stealing electrons, of course, electrons are negatively charged, so they're stealing negative charges. So the bottom gets this big negative charge, and that big negative charge in the bottom of the cloud causes electrons to run away on the ground because they are repelled by the cloud. And then the ground develops a positive charge. Of course, you know positive and negative charges attract and want to get together, and that's how you end up with lightning. This is 10. Which is responsible for most of the light and sound in a lightning bolt, the stepped leader or the return stroke? And like I said, Mrs. Hastings has a great video where you can really see it better than any videos I've seen. So you really want to get on her website and watch that. But the cloud forms the stepped leader from the negatively charged bottom of the cloud, but then the return stroke, which is where the light and sound comes from, comes up from the ground. Number 11, where does the thunder and a thunderstorm come from? So as the negative cloud and the positive ground fight to let their charges get together through the insulation of the air, it requires a huge amount of energy. And so when it happens, lightning will superheat the air around it. That release of that energy, it can heat the air very, very hot. And when that air is heated, it expands, it rushes out, and those rushing waves, if they strike your ear, vibrate your eardrum, that is what we perceive as sound. Let's see, number 12. Why do lightning bolts tend to strike targets that are high? Tall things develop a greater positive charge, and because they're closer to the cloud, there's less air insulation to fight its way through, so that it's easier to overcome the insulating properties of air and get those negative charges and positive charges together. Let's see. Number 13. What is the difference between sheet lightning and a lightning bolt? Sheet lightning, I didn't talk about this in the other video. Sheet lightning is what you would call cloud-to-cloud lightning. It never actually strikes the ground. It's just, the bottom layer of a cloud is negative, top layer of a cloud is positive, so sometimes you'll get cloud-to-cloud lightning where those charges are trying to redistribute themselves, attract the attractive forces between the opposite charges. So cloud-to-cloud lightning, just light and heat, but not actually hitting the ground. A lightning bolt is cloud-to-ground lightning. And next week we'll talk about everything after that in the chapter, tornadoes, hurricanes, things like that. Let's see, I think we've covered everything pretty well. So if you have questions about the summary in the back of the book, make sure you do that summary. I can answer any questions if there are blanks you can't fill in class. You can, once it's completely done, you may ask your mother to check through it and tell you if you've got any wrong. That's fine too. And I will see you on Tuesday. Hope you had a great day off yesterday.